Hidden deep inside the earth, silver lies trapped inside rugged rocks. But turning these rocks into gleaming coins or jewelry, that requires massive machines, bubbling chemicals, and extreme heat. Want to see how raw stone becomes pure silver? Let's uncover the fascinating process. Don't forget to like the video and subscribe. The journey from hidden rock to promising ore starts long before any digging begins. Over millions of years, volcanic activity and hot fluids deposit silver in fractures and voids underground. These natural forces leave behind silver-rich zones, but they're mixed with lots of other minerals, all tucked deep beneath the surface. To track down these hidden deposits, geologists use a mix of science and detective work. Soil sampling is a key tool. They collect and test soil from different spots to look for traces of silver that might have leached up from below. Another favorite technique is seismic imaging. This sends sound waves pulsing into the ground and records how they bounce back, giving experts a picture of what's going on down there. It's a bit like giving the Earth an ultrasound to spot the best places to explore further. Next comes drilling cores to test silver content. Crews drill down and pull up long cylinders of rock which get sliced and studied in the lab. Only some sites pass the test. If there's not enough silver or if the rock is too hard to mine, the project stops there. Mining companies also weigh access to roads and environmental impacts before greenlighting a project. It's not just about what's in the ground, but also how practical and responsible it is to get it out. Once a site is approved, preparations begin. Workers clear away surface plants and topsoil, exposing the ore beneath. This step makes room for heavy equipment and gives geologists a better look at the rock formations they'll be working with. It's a careful process, since disturbing the land can affect local habitats, so teams often work with environmental experts to plan the best approach. After all that, the ore is finally within reach. But finding silver is only half the challenge. The real work begins when it's time to separate the silver from all the other stuff it's mixed with. That's where things get complicated and a little bit messy. Silver doesn't just sit in rocks waiting to be picked out. It's tightly locked within a mix of other minerals and debris, so getting it out takes some clever moves. Breaking and bubbling. The silver separation story starts with massive crushers grinding the rock into a fine powder, freeing silver particles. This powder is the starting point for separating silver from everything else it's mixed with. For ore rich in silver sulfides, the next step is called flotation. Think of a chemical bubble bath. Powder, water, and collector chemicals churn together in a tank. These collectors make silver particles repel water, hydrophobic, so they ride bubbles to the surface. Air is pumped in, and as bubbles rise, silver particles stick to them and float up. At the top, a frothy layer forms, packed with silver. Workers skim off this froth, while the unwanted material, called gangue, sinks to the bottom. This method is efficient at concentrating silver, making it much easier to process in later steps. Not all silver ores are the same, though. For some, especially those containing silver chloride or native silver, a different method comes into play: cyanide leaching. Here, the powdered ore is mixed with water and sodium cyanide in a tank. Oxygen is bubbled in, which helps the cyanide dissolve the silver into a liquid solution. The result is what miners call a pregnant solution, loaded with dissolved silver cyanide. The leftover solid waste is filtered out and discarded. No matter which method is used, the goal is the same: separate as much silver as possible from everything it's trapped with. Both flotation and cyanide leaching transform raw powder into a concentrated silver material, but our silver is still mixed with impurities. Next, we turn up the heat to melt them away. Fire and electricity are the keys to making silver pure enough for use. After flotation or cyanide leaching, the concentrated silver still carries traces of other metals and minerals. The next step is smelting, where the silver concentrate goes into a furnace or kiln heated to extremely high temperatures. As the furnace heats the concentrate, lighter impurities form a slag that's skimmed off, leaving molten silver that's about 85 to 95% pure. The silver, being heavier, sinks and can be collected at the bottom. Once cooled, this smelted silver takes the form of a metallic button or bar, but it's not quite ready for its final roll. To reach the highest purity, what's needed for electronics, jewelry, or medical tools, silver goes through electrolytic refining. In this process, the impure silver bar is placed in an electrolytic cell filled with a special solution that conducts electricity. An electric current dissolves the impure silver anode, then deposits pure silver onto the cathode, leaving impurities behind as sludge at the bottom of the tank. Slowly, layer by layer, the cathode collects silver that's now 99.9% pure. This stage is essential for producing silver that meets strict industry standards. The process is carefully monitored to make sure every bar reaches the purity needed for whatever comes next. Each batch is tested, weighed, and checked for any lingering impurities before it moves on. Next, we'll shape these ultra-pure bars into the things you use every day. The silver's journey isn't over yet. Now it's time to see how these refined bars are transformed into familiar forms, ready for all kinds of uses. A shimmering finish. From bars to everyday use, with silver refined to its purest form, the next phase is all about shaping it for the world. Molten silver, heated to around 3,245 degrees Fahrenheit, the melting point of silver, is poured into molds designed for everything from small ingots to hefty bars. Think of it like pouring cake batter into perfectly sized pans. Molds ensure each ingot meets precise weight and purity standards, so every bar is ready for whatever comes next. After cooling and solidifying, the silver is removed from its molds. Each hardened ingot undergoes purity tests to confirm it truly hits 99.9% before packaging. Quality control is strict. Inspectors look for any imperfections or irregularities that could affect the silver's value or performance. Only bars meeting every requirement move forward. Once approved, the silver is wrapped and packed for shipment. Packaging isn't just for looks. It protects the surface from scratches, tarnish, or contamination during storage and transit. From here, the journey branches out. Some silver goes to jewelers who melt and craft it into rings, bracelets, and necklaces. Other bars head to mints, where they're pressed into coins or made into investment-grade bullion. Industrial clients get their share too, using silver for electronics, medical tools, and more. Silver's versatility is what keeps it in demand. Its high conductivity makes it essential for electronics. Tiny amounts connect circuits in smartphones, computers, and solar panels. In the medical world, silver's antimicrobial properties are put to work in wound dressings and surgical instruments, helping fight infection and speed up healing. Some bars become smartphone components, others become silver-coated surgical tools. Proof that this journey underpins modern life. Every step, from casting to inspection to final use, is about precision and purpose. The silver you see in everyday objects carries the story of intense heat, careful shaping, and relentless quality checks. It's easy to overlook the science and engineering behind something so familiar, but silver's journey shows just how much work goes into making the ordinary extraordinary. And when you pick up a coin, wear a necklace, or power up your phone, you're holding the result of a process that started deep underground and ended in your hands. Silver's transformation from buried ore to finished product is a story of science, skill, and resourcefulness. Every stage, geological surveys, mining, crushing, chemical separation, smelting, and refining, shows just how much effort goes into creating the materials we rely on each day. If this journey from rock to silver amazed you, hit like and subscribe for more hidden stories of everyday materials. And here's something to think about. What other ordinary items have secrets as shiny as silver's? Let us know your guesses or favorites in the comments below.